Okay, welcome back to part 3. And in this part of our workshop, let's go ahead and write that assemble function, right? If you remember, we had at the very end in our try catch block, we had this assemble function. So let's go ahead and write that. So what is this assemble function going to do? Well, it's going to be our control function. It's going to control the work of assembling. Not that there's going to be a whole lot of work to control, but it's good to have that all, I think, in one place. Helps us more easily remember where it is and what we're actually doing. So assemble is going to take two arguments, right? It's going to take our input and our output classes, our new objects that we created. And so we come actually up to a really interesting problem for really all assemblers. If we read through our assembly, it is possible, and I'll pull it up here. So we have these labels here on our left-hand side. Well, something that's really interesting, something that we actually see here is that if we have a label and we write the label, and then later on in the code we call the label, then that's fine because we've actually declared the label, and then after we've declared it, we've called it. But if you notice here with this message label, we're actually using message before we've declared it. So we have this really interesting catch-22. How can you use something before you've declared it? If you ever coded in C, in particular C or C++, and you have written a function and you had forgotten to declare it, you'll get a nice error message saying that you're trying to call a function before you've actually declared it. D is really nice in that it's actually going to do the same trick we're going to use here. So D is actually going to know what all of your functions and all of your labels are before it starts doing the work of compiling. But we need to do the same trick here in assembly. So traditionally, assemblers are what we call two passes. The first pass is we're just reading through the code, and all we're looking for is our declarations of our labels. And we're going to remember what address each label is at. And then through the second pass, that's when we're going to actually do the work of assembling our instructions into binary. And in the second pass, because we already know the addresses of our labels from the first pass, it's not going to matter that message is used before it's declared because we've already gotten that information. We already know that information during the second pass when we're actually using it. So that's really the traditional way of producing assemblers, this two-pass methodology. Again, D is really nice in that it's also going to be doing that. So if you notice, I don't ever declare any of my functions. We don't need to. D is going to collect that information for us before we actually do anything useful with it. All right, so we'll say we need two passes for our assembler. Pass 1 collects addresses for symbols. Pass 2 processes assembly into binary code. For each pass, we need to parse a line and perform the work. So what I'm going to do here is we're going to need to have some sort of variable that's going to store which pass that we are on. So the question becomes, does it make more sense to put things in the input object or the output object? I'm not sure it matters all that much, but just for my thinking, I am thinking of remembering what pass we're on as part of the work that we are doing to create our output file. So I'm going to put pass inside the output class. You can choose to agree or disagree with me on that determination, but that's what I'm going to choose to do. And so no matter what, for each pass, the first thing we want to do is reset what line that we are on, right? And lines always start with 1. There is no 0th line. We're going to start our lines at 1. But we don't want to have a case where we find an error in the second pass and we end up spitting out a line number that's twice as large as the actual input file itself. So we just need to remember to reset input line to 1 at the beginning of each pass. And then we can use the for each loop, and we can say for each line in input lines. And you'll notice I did not previously specify what a line is. D is going to just know what a line is, and line is going to be a string, right? Because input lines, as we remember, is an array of strings. So we can say for each line in input lines, the first thing I'm going to do, and it may not make much sense now, but we will see when we get to our parser, is I'm going to put a null byte at the end, just so we have some sort of character at the end of all of our input lines that we know can't possibly belong to anything that we wrote. And we'll see kind of how that comes in handy when we write our parser. So what's the next thing we have to do? So for each line, well, there's a couple of things we have to do. So first, let's take a look at what a line actually is. So a line in assembly can be, well, in this case, totally blank. It can have nothing in it. It can just be a comment. It can either have a label, or in this case, not have a label, or have a label. It has some sort of instruction. Some instructions don't take any arguments. Some instructions take one argument, and some instructions take two arguments. And then they may or may not have a comment at the end of their instruction. All right, some do, and some don't. So with that in mind, we're going to sort of impose what a assembly line can look like. So I'm going to say an assembly, or I'll say a line of assembly is 1, an optional label, 2, mandatory white space, 3, an optional instruction, and then optional comment. And so we can actually use this kind of predetermination of what a line of assembly is to kind of help write our parser a little bit, but also kind of have us think now about what it is we need to do. If a line of assembly is a label, an instruction, the arguments to that instruction, then we need to find a way to split the line that we currently have into those different parts, where those different parts are a label, an instruction, and its arguments. So we need to essentially break these down into kind of a smaller unit of work, which we're going to call tokens. We're actually going to create a new class for this, a tokens class. We'll worry about it in the next video. But for now, we'll say tokens equals new tokens. And just like we do with our input, with our tokens class, we're also going to feed it a line. So when it gets constructed, it will parse that line into its tokens. And that way, the parser itself will actually become part of the tokens class. And then we'll need to process those tokens. So we'll say process tokens, and we'll probably need to deal with our input and our output as well. So we'll make all three of those things arguments to our process function. And then after we process things, we'll need to increment our line number, since we will now have the next line to worry about. If we have been totally successful out of all of this, and that means we have completely processed and assembled our input into output, then we can go ahead and write our output, which is why we wrote that output method in the output object in the previous episode. And that's really all we need. That's all the control work we need for our assemble function. One thing you might be asking to yourself is, well, wait a second. Why do we have to process each line into a token twice? Can't we just remember the tokens of each line? And the answer to that question is yes, you could. But one of the things that I'm trying to go for in this workshop and with this code is kind of making it kind of a stretch enough for someone who might be brand new to all this stuff to still be able to follow along and be able to walk away from this with not just some code that they wrote that's interesting, but the actual capacity and ability to explain that code to their friends. That's kind of the goal that I'm trying to reach here. And so while you're right, we could save everything, and that way we don't have to parse things twice. It would be more work to have to save it somewhere and then refer back to what we saved. it is going to be true that if we successfully parsed our lines in pass 1, we will again be able to successfully parse our lines in pass 2 because we're not modifying the lines. We're just parsing the lines, but we're leaving the lines intact as they are. So because we're not modifying the input lines at all, if we're successful in parsing them once, we must be successful in parsing them twice. And we'll leave it to our process function to determine what to do depending on which pass that we are on. And that's really all we need to do here. So I'm going to go ahead and save our work. I'm going to commit our work. And that's going to be it for part 3. And see you again in part 4.